In this video, we're going to redo a review of ionization. So let's start with a really simple Bohr model of an atom. And let's identify where our valence electrons are. So valence electrons are our outermost electrons. So in this case, those would all be valence electrons. Okay, so the outermost electrons are valence electrons. If you look on your periodic table, the group numbers, so 1A, 2A, go across the table to the other side, 3A, 4A, so those are all the number of valence electrons for every single element in each group. So for example, hydrogen, lithium, sodium all have one valence electron. Beryllium, magnesium, calcium all have two valence electrons, and so forth. Okay, so those are valence electrons. Those are an important concept that you need to know. Okay, now on our periodic table, everybody wants to be like the noble gases, which exist here in group 8. Those all have 8 valence electrons. They have a completely full outer shell. So let me give you an example. Eight is the magic number that we want. Okay, when you have 8 valence electrons, you have a full outer shell. So everybody wants to get to that point. Everybody wants to have a full outer shell. Everybody wants to get to 8. Okay, now, it's not easy for everybody to get to 8. Sometimes, I don't know why I did that one in black, but sometimes you need a lot to get to 8. So in this example, I have 3. If you have between 1 and 3 valence electrons, you are going to lose them to get a full outer shell below. So 1 to 3, you are going to lose all valence electrons, and you will gain a positive charge. So if I had 3 and I lost 3, I would have a charge of positive 3. If you have between 5 and 7, you are going to gain 2, 8, and you will gain a negative charge. So we're going to do a couple of examples where ionization happens and you need to figure out the charge. So let's pick an element on the periodic table. Let's do magnesium. Okay, so magnesium on our periodic table is right here. Magnesium is in group 2A, so it has 2 valence electrons. It falls in the range of 1 to 3, so it is going to lose those. If it loses 2 valence electrons, it now has 2 more protons than electrons, so it will have a +2 charge. What about oxygen? Oxygen is right here. Oxygen has 6 valence electrons. It needs 2 more to get to 8. It falls in this range right here. It needs 2 more valence electrons to get to 8. So it's going to gain 2 more electrons. If it gains 2 more, it'll have a charge of -2. All right. What about aluminum? Okay, so I want you to just pause the video for a second. Like actually do it. Like actually pause the video right now. How many valence electrons does aluminum have, and what would the charge be? All right, hopefully you pause the video and work this one out. So aluminum has 3 valence electrons. If it has 3 valence electrons, it's going to lose those, and it will have a charge of +3. Okay, let's do one more here. let's do selenium. Okay, so actually pause the video and figure out the charge of selenium when it ionizes. Okay, selenium, Se. Selenium has 6 valence electrons. It needs 2 more to get to 8. If it gains 2 electrons, it will have a charge of -2. So, in summary, going across the periodic table, these are the charges. We have +1, +2, +3. We're going to skip this one. -3, -2, -1. Okay, and remember, the noble gases have 8. They're already cool. They don't need any more valence electrons. Okay, so you need to know these charges. You need to know the valence electrons. But you get to use your reference sheet, and if you can remember valence electrons by the groups, shouldn't be too terrible. So that is our review on ionization.